Now let's consider this example. The operation star is defined over the set of ordered pairs by A, B, C, D star, C, D equal to AC, comma, A, D plus, and B, C, where A is not equal to 0 and A, B, comma, we have C, D is a member of what? R squared. What we were doing previously is a member of what? R, but in this case, we have R squared. Now the question we should determine whether or not star is commutative. So now when it was in R, that is, we know that a binary operation is said to be commutative if that is A star B is equal to B star A. But here in this case we have two elements. So here we can say that star is commutative if for all, that is A, B, C, D, a member of R squared, that is A, B, star C, D is equal to, we have C, D, star A, that is AB, that is AB. Now, we were given, from the question, we were given that that is AB star C D. AB star C D, we're given as what? That is AC, comma, and then we're given that is AD plus BC. From the definition, from the rule given to us, that's AB star C D is given us what? AC, so A times C, that equal to AD plus BC. So let's say this is equation 1. Now let's also find that is C D star A B. Now from the definition, this is what? The first times the second. So the first element times the first element of the second one. So that is C A, comma. Now what does it say? It is saying that the next one should be, that is A D. So that is C B plus. Now, so that is AD plus BC. So that is DA plus DA. Now let's take it again. Now AB star CD, it is saying that what? A times the first one. So we have AC over here. Then we have AD plus BC. So here, this time this, that is CA, that is what we have here. And then the next one is what? CB plus DA. Now you can rewrite this as what? AC, comma. Now CD and then DA, we can rewrite so that it will look the same as this. So that is AD plus, now CB is the same as what? BC. So this is equation 2. So clearly equation 1 is equal to what? Equation 2, which implies that AB star, that is CD, is equal to, that is CD star AB. Therefore star is commutative. It is commutative. Now the B says that, what is the question B saying? Question B says that we should determine whether or not star is associative. Now star is associative if for all we have AB, we have CD, we should get 3 elements, that is EF, a member of R square, that is AB star C B star EF. So we take the first 2 and it's equal to, that is AB star CD star, that is EF. So that one we take the next 2. So first we consider the left hand side. Now for the left hand side, we know that if you have, that is, we know that, let's come here, so we know that A, B, star C, D. Now this is equal to, we're giving us what, AC, and then this is what, AD plus BC. This is the definition. So that is A, comma B, star C, comma D. That's it. Now we know that third, so we have to bring the third element, that is A, B, star C, D, star E, F. Now what is A, B, star C, D? Now binary operation, we need to consider two elements at a time. So considering this element, this is the definition, that is AC, comma, we have AD plus BC star EF star EF. And using the rule, what is the rule saying? The rule is saying that is A times C. So this times the first one. So that is what ACE. And then what does it say? So that is, and then the next one is what? That is AD. AD. We have here AD. So AD. Now these are A. So AC times that. So that is ACF. And then plus B times C. That is B times C. So this is our B. So AD plus BC and then times E. So that's what we have here. So AC, AC. So this one times this. Does give us this. And then the next one says what? AD. So this times F, ACF, and then plus BC. So this times that. So when you expand, what are we getting? We'll be getting, that is ACE, ACF plus ADE plus BCE. Expanding this would give us that. Now let's call this, that is equation 1. Now let's also consider the right hand side, which is A star B. So let's consider this. So we'd also consider AB star, that is we have C, D star E, F. So first, what do we need to do first? The bracket first, the bracket first. So we have C, D star E, F. We have to consider this first. Now what is the rule saying? That is A times C. So this are A, and then this is C's are E. So that is, so this will give us, that is C, E, this time this, then comma. Now it is saying what? AD. So AD. So that is CF, CF, CF. That is CF. Look at this. That is what? AD. So AD. So C and F plus. Now BC. What is our B here? And then what's our C here? E. So that is DE. Now let's bring the third element. So we have A, B star, we have C, D star E, F. And this is equal to, we have A, B. But then what is C, D star E, F? This is the result, that is C, E, C, F plus D, E. Now using the rule, which is what? AC. So this time that. So that will give us ACE, comma, and then AD. So ARD is what? CF plus DE plus plus BC. So plus B, so BCE, and plus this time this from the rule. So from here we have ACE, comma, this will give us, that is ACF plus ADE plus B, C, E. Let's say this is equation 2. Now let's see if this is equal to this. We have ACE, ACE, ACF, ACF, ADE, ADE, BCE, BCE. So clearly, equation 1 is equal to equation 2. Therefore, we can see that star is, that is what? Associative. Yes. In fact, this is quite confusing. Take the questions yourself, take a piece of paper and try them yourself. Don't just watch, solve along, and make sure that you understand it very, very well. Don't forget to call for a copy of the books that you are seeing on the screen to give you a firm foundation in maths. And if you have not subscribed my YouTube channel, make sure that you do that. We have a lot of videos to help you pass your exams with ease. Now let's see the question C. The question C says we should determine the identity element. So first, let's write the rule down. So the rule given us is that is AB star CD, and this is equal to, that is AC, and it's giving us AD plus BC. This is the rule given to us. Now we can see that that is E1, E2, a member of R square, be the identity element. Now, what's the definition for the identity element? We know that for all A, B, a member of R square, because the identity is unique, we say that there exists, that is E1, E2, a member of R square, such that is A, B, star E1, E2 is equal to, that is E1, E2, star AB, and this is equal to AB. But then, but from the definition, we know that AB star, we have E1, E2. From our definition, this is equal to, it says what? AC. So the first of the second one, so that is E1, then comma. The next one says what? AE2 plus, that is BE1. But then from our definition of the identity element, AB star E1, E2 is the same as what? AB. So you have AB here equal to, that is AE1, AE2 plus BE1. So here equating, clearly this first element is equal to what? This first element. So we see that this implies A is equal to AE1. The first element is equal to the first element. Finding E1, we can divide through by A. So A over A, AE1 over A. This cancelling out that. So this implies that our E1 is equal to 1. So this equal to 1. Also, the second element, B here, is equal to AE2 plus BE1. Now, what is E1? E1 is equal to 1. So we have B is equal to AE2 plus B. Because E1 is 1, so 1 times B, that is that. Finding E2, so what do you have? This B. So grouping like this, that's B minus B equal to AE2. Now what is B minus B? That is 0. So you have 0 equal to AE2. So finding that is A2. So our E2 is equal to 0 over A. Now we have been told that the A is not equal to 0. From the question, we have been told that A is not equal to 0. And because it's not equal to 0, this is defined. Hence, our E2 is just equal to 0. Therefore, our identity element, that is E1, E2, is just 1 0. Wow, that is easy, very, very easy. Now the third one says that we should find the fourth one, the D says we should find the inverse. The fourth one says we should find the inverse. Now, so you can say that let's A inverse this, that is B, the inverse, be the inverse of A, B. Now, what is the definition of the inverse? Now, we know that for all that is A, B, a member of R square, the inverse is unique. We say that there exists, that is A inverse, B inverse, a member of R square, such that that is A, B star A inverse, B inverse is equal to, that is A inverse, B inverse star A, B, and this is equal to the identity element, but then the identity element is 1, 0. Now, what's the definition? But A, B star A inverse, B inverse is equal to, now using the definition, what's the definition? It says what? AC, so that is A times A inverse, so A inverse, comma, now AD, so this are D, so yeah, A, D, and then plus we have B, A inverse. Now, what is this time? This operator, this is identity element, which is 1, 0. So you have 1, 0 is equal to A inverse, A, B inverse plus B, A inverse. So we want to find A inverse and B inverse. So clearly, what do you know? 1 is equal to A inverse. The first element is equal to the first element here. Therefore, that is A inverse is 1 all over A. 1 all over A. Now the second element, we know what? 0 is equal to what? A, B inverse plus B, A inverse. Now, I want to find B inverse. What is A inverse? A inverse is 1 over A. So substituting A inverse over here, you have 0 equal to A, B inverse plus B. But this is giving us what? 1 over A. 1 over A. So working it out, we have 0 equal to A, B inverse plus B over A. So this can go to this side, or we can multiply through with the LCM, which is A. So you have A times 0 equal to A times A, B inverse plus A times B over A. This is 0, and it's giving us A0, B inverse plus B. We want to find B inverse, so this has to go here. So you have negative B equal to A squared B inverse. Therefore, B inverse is what? Negative B all over A square. Hence, our A inverse, B inverse is just equal to, now what is A inverse? We have our A inverse to be 1 over A. 1 over A. And then what is our B inverse? Is what? Negative B all over A square. That is so easy. Now let's see our question E. Let's see our question E. What is our question E saying? Our question E is saying that we should determine the inverse of 3 and then 2. So we want to find the inverse of 3 and 2. So that is 3 inverse, 2 inverse. Now, what is our A? 3. So here this what? 1 over, what is A? 3. And then here what do you have? Negative, you have B. What is B? 2. But then what is A? We have 3 square. And that's just, that is 1 over 3. And then that is negative 2. 3 square is 9. Please, you can play back the video several times for better understanding. Call for a copy of the books that you are seeing on the screen. It will give you a firm foundation in mathematics. And also, if you have not subscribed to my YouTube channel, please make sure that you do that over there. I also have a lot of videos over there to help you pass your exams with ease. You can call the numbers that you are seeing on the screen now for a copy of the books that you are seeing on the screen. Don't forget to call, and then don't forget, no pain, no gain. Mathematics is not a spectator of sports. All that I'm doing, I didn't do it easily like that from the beginning, but then it took me effort. I have to sit down, solve questions on my own after listening to the lectures for better understanding.